Now, a British company has just tested its first launch-capable high-power chemical rocket engine. Pulsar Fusion, a nuclear fusion company based in Bletchley, has high hopes for the use of its engineers in interplanetary travel, and it believes its technology could eventually cut the journey time to Mars in half. Well, joining me now is Pulsar Fusion's Chief Executive, Richard Dynon. Richard, welcome to you. Why was this test so important to you?
Right, well, I think it was important to us because it's a British rocket test, and we don't really see many of them. On top of that, it's been built by British scientists, and it's, we don't really have rocket launches every day in this part of the world. As a company, it's massive. It's the first test where we've actually tested a rocket engine in the field. So, yeah, all pretty big events.
Now, the rocket was propelled by nitrous oxide and polyethylene. Why didn't you go with conventional rocket fuel?
So this is it's a hybrid engine, as you say. So a high-density polyethylene and nitrous oxide mix. It binds together to give a very clean, sort of non-toxic plume, which is relatively rare, actually, in rocket propulsion technology. And it's very clean, very quick to make, and very powerful. So we think it's a commercial design, and we've got a lot more testing to do, but it's shown very, very promising results. It's very commercial for applications in Europe and the UK.
Now, ultimately, obviously, you want to power a rocket using fusion power technologies. How did the test help to that particular end?
Right. So we're a propulsion company. We already build satellite engine propulsion systems for use in space. This technology was our ability to get from ground to low Earth orbit. So if you like, getting into the ground to space, we've got that technology, and moving around in space and space adjustments and satellites, we have that tech. The next step for us, as you say, would be meaningful or relatively meaningful distances in space. And to travel long distances in space, the distances are so massive, you need very, very high exhaust speeds. And we just don't get very far by setting fire to things, which is a theme really across all technologies. Nuclear fusion, not fission, gives us the ability to have about 1,000 times the propulsion speeds of conventional space ion thrusters. So it means that if we want to start looking at planets or ever leaving our solar system, it won't be done by combustion rockets. It's got to be nuclear, and it's a very clean version of it. It's not like fission, so there's no sort of long-lived radioactive waste that people are sort of familiar with when you talk about nuclear.
Absolutely. Now, what are the next milestones?
So we tested our air-breathing engines now. We tested our orbital engines. The next milestone for us is to commission a nuclear fusion static test, which means we tested in England on the ground before we try and do it in orbit. We aim to do that in 2023, and then in 2027 we'd look to do an in-orbit demonstration of our nuclear fusion propulsion design. So it's ambitious, but it's extremely exciting. And having a test, successful test of our other technology it shows that we can build things on time, on budget, and we've got some amazing scientists in this part of the world. We really do.
Yeah, long way to go. So how much is that going to cost you to achieve this test in 2027?
So it's going to cost us, a static test beforehand is about 20 million, and then probably another 150 million for an in-orbit demonstration. And that's actually relatively low costs when you're talking about nuclear fusion. The propulsion aspects don't require all the immensely expensive power station infrastructure that surrounds a lot of these fusion designs. They sort of cost into the billions. The propulsion side of it is actually relatively simple, and space being minus 275 degrees, it's about 0 Kelvin. It's ideal for superconductors, and it's a natural vacuum. So you've got a lot of things going for you in terms of stripping out sort of expensive sort of infrastructure. But yeah, it's still significant investment.
Absolutely. Richard, good to see you again. Thanks very much for joining me today.
Yeah.